Let's talk about the Pythagorean Theorem, which is a way to calculate the side lengths in a right triangle. But first we need to identify the different parts of a right triangle. Every right triangle, of course, has one right angle, and then the other two angles are acute. And every right triangle has one side that we call a hypotenuse, and then the other two sides are called legs. The hypotenuse is the side that is across from the right angle, and the legs are the sides that create the right angle. So these two sides, AB and BC, are legs because they create the right angle. The right angle is angle B, AB is one of the segments that creates the right angle B, and BC is the other segment that creates right angle B. So that means that these two segments are called legs. And that means that the third side is called the hypotenuse. The hypotenuse is the side that is across the triangle from the right angle. You can actually think about that little square like an arrow. That arrow points at the hypotenuse, and the hypotenuse is always the longest side of the right triangle. And when we talk about the Pythagorean Theorem, which you probably already know is a squared plus b squared equals c squared because you learned that in middle school, c is the hypotenuse, and a and b are the legs. It doesn't matter which side you call a and which side you call b, as long as a and b are the sides that create the right angle, and c is the side that is across the right triangle from the right angle. Then you can use this formula to calculate their lengths. A squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. So let's give it a try. The first thing that we need to do is identify which sides are legs and which side is the hypotenuse. 8 and 15, or DE and DF, those are the legs of this right triangle because those are the two sides that create the right angle. And FE is the hypotenuse because it's the side that's across the right triangle from the right angle. So my formula tells me a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. So I will write that 8 squared plus 15 squared equals FE squared. The order of 8 and 15 doesn't matter. You could have also written 15 squared plus 8 squared, and as long as you're setting it equal to the hypotenuse squared, FE squared, it's good to go. So let's simplify. 64 plus 225 is 289. Square root both sides to get FE completely alone, because right now it says FE squared, and we need to get rid of that squared. The opposite of squaring is square rooting, and the square root of 289 is 17. So FE must be 17 kilometers long. Let's try another one. Again, the first thing you need to do is identify which sides are legs and which side is the hypotenuse, because you're not always going to set it up like we did on the previous problem where you square both of these numbers and add it together. In this case, these two sides are the legs. I don't know one of the legs' measurements, and 37 is the hypotenuse. So I need to write that 12 squared plus IH squared equals 37 squared. So I'm not setting it equal to a variable squared this time. This time my variable is on the left-hand side of my equation because it's one of the legs that I'm missing. 12 squared is 144, 37 squared is 1369, then I'll subtract 144 from both sides, and then square root, and I find out that IH must be 35 feet long. Our next problem is kind of similar because we're missing a leg. These two sides are my legs, and this side is the hypotenuse. So the equation that I'll write is 10 squared plus kj squared equals 11 squared. So 100 plus kj squared equals 121, so kj squared equals 21. However, when I square root both sides, I don't get a pretty answer. There is no perfect square root of 21. So just give me a decimal approximation rounded to the nearest tenth. Kj is about 4.6 centimeters. Well, let's try a more complicated example. We need to calculate the value of x and the value of y. And I see a couple different right triangles here. This is the only right angle that I see that's labeled, but this angle right here would be right as well, because 90 and 90 would give me a total of 180, and PO is a straight angle, that equals 180. So both of these triangles are right triangles. So if I'm going to calculate the value of x, I really just need to focus on this right triangle. X is one of the legs, 28 is another leg, 53 is the hypotenuse. So the equation that I can write is that 28 squared plus MP squared equals 53 squared. Or instead of MP, you could also just write x. So 28 squared is 784, 53 squared is 2809, Subtract 784 from both sides and square root, and we find out that x must be 45 inches long. So how am I going to figure out the value of y? Well, it's the hypotenuse of this right triangle, NPO, but I only know one of its legs, not the other leg. How am I supposed to figure out the length of PO? Well, I know that MO is 66, and we just calculated the length of MP to be 45. So I can calculate PO by subtracting 45 from 66. PO must be 21 inches. Now I can focus my attention on just this right triangle. 28 and 21 are the legs of that right triangle, and y is the hypotenuse. So I can write this equation. PO squared plus NP squared equals NO squared. In other words, 21 squared plus 28 squared equals y squared, which would be 441 plus 784, which is 1225, square root that, and we find out that y, which is also the length of NO, is 35 inches long. And that's the basics of what you need to know about the Pythagorean theorem. In the next part of this lesson, we're going to discuss the converse of the Pythagorean theorem, which is what we're going to use to determine whether or not a triangle is a right triangle.